Okay, so we're investigating the laws of logarithms, right? This is tape 2. What is a logarithm?
An exponent.
An exponent. An exponent is just a number, right?
Yeah.
Okay. So we're going to go through this. Log base 2 of 2. So it says 2, the base, to the power of what gives me 2?
1.
Log base 2 of 4. Log base 2 of 8.
3.
Log base 2 of 16. All right, so you can fill in the rest of this, right? So the log is an exponent. It's the exponent that we raise the base 2, or the base 2 to get the number or the value, or that's called the argument. And we're just going to use these values, right, in filling in this investigation. So it says use the above values to help you complete the following. And so the first one is done, right? Log base 2 of 4 plus log base 2 of 8. Well, log base 2 of 4 is 2. Log base 2 of 8 is 3. 2 plus 3 is 5. And looking in the table, 5 is the log base 2 of 32. Okay, so you would fill that in. So on this next line, log base 2 of 2 is?
1.
And the log base 2 of 32 is?
5.
1 plus 5 is?
7. 6.
And 6 is the log base 2 of?
64.
64, right? Okay, so fill in the rest. I will drag this down a little, and I will pause it and fill it in myself. Okay, so there's everything filled in. Somebody want to verify? Yes, no?
Never mind.
What? Figured out?
Just if the 8 and 2 were switched.
Oh.
The last one.
The 2 has to be in front because that's log base 2 of 4.
Okay.
So we know that this here corresponds to this 2. So this has to be an 8 in order to add up to 10, right? It's just a little puzzle line thing, right? Like, okay, how do you get this number from that?
Are we going to have questions like that?
Yep.
Can you take a picture of me? When's the test for this unit? After spring break.
There you go. After spring break. It's like April 3rd or something. I don't know. We're back on the Tuesday, and we've got a period, and then probably a review period. All right, now what we want to do is take a look at the first expression, like log base 2 of 4 and log base 2 of 8, and compare that to the last expression, and do that with all of those, and figure out, all right, what's log base 2 of 2 plus the log base 2 of 8?
Oh, wait.
It's like
16.
16. I'll go with that. What's log base 2 8 plus log base 2 8? 64. What's log base 2 16 plus log base 2 4?
Oh. 64.
And what's log base 2 2 plus log base 2 of 64? And how are you getting these numbers? Multiplying them, right? So, our first law of logs, known as the product law. Log base a of m plus log base a of n is equal to log base a of mn, right? The mn. Or log base a, what goes in the blank, is equal to log base a m plus log base a n. Mn. So, in other words, or actually in words, because the other one was formula, in words, the sum of the logs of two numbers is equal to the log of the, which is the fancy math word for,
Not the sum.
not the sum,
Product.
product. See, better than the last class already. It took like, I don't know how long to get product out of them.
You know, they want to watch this video and they won't appreciate your watching their class.
Oh, nobody's going to watch this. Don't kid yourself.
I just watched it. I watch it.
Okay, maybe some. If we check the views, it'd be like 3 views or something, right? I mean, there should be. How many people are missing? Like 3 in the hall, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we're missing like 4 people. Yeah. Okay. The log of the product is equal to the
Sum.
of the two numbers, right? So this law works both ways. You're only given one form on your sheet. I think it's this one. Log base A of mn. The log of the product is equal to the sum of the individual logs. But it works both ways, right? So if you're given an expression that looks like this, you know it's equal to this. And if you're given an expression that's a product, you know it's equal to the sum. So if you're given a product, you can split it out and write it as the sum of individual logs, right? You're going to say the log of the first factor, the log of the second factor. And if you're given an addition with logs, you know that you can write it as a product of what's there. And this applies to more than one thing, right? It could be m and n and o and p, and then this would be m times n times o times p. So let's use our rule to express log base 264 as the sum of two logs in as many ways as you can. So we could say it's log base 264. Log base 264 is equal to log base 2 of 1 plus log base 2 of 64. What other numbers could we use here? 2 and 32. What's important about the two numbers?
Their product is 64.
Exactly. And make sure you're writing base 2 logs, right? We always have to use that base of 2. This only works, this rule, right? It's log base A, and everything's base A. So everything has to be the same base. It won't work if you got a base 2 log and a base 5 log and whatever. Okay, let's do a couple more. And I don't know, is there one more? Okay, so what other numbers? I got 2, 1 and 64, 2 and 32. 1 and 64, 2 and 32.
Something and 16. 4.
4 and?
16. I said something and 16.
And what else?
8 and 8.
8 and 8. What else? 6 would work, but it's kind of awkward.
You're awkward.
Who used to do that to me? There was a class, and I would get a kid do that all the time. Oh no, yeah, it was like last year in 20 IB. You say, Anita, you need to work on your material. Works good once. After that, it's just sort of really come up with something new.
And then just says you need to work on your
Okay, I know you're offended.
I always come up with something new. Guaranteed every day. Something new. So what if we said 64 over 3 and 3?
That'd be silly.
It would, wouldn't it? But it would be log base 2 of 64, right?
Yeah.
Because I would take these, as long as I have two things that multiply together to give me 6. See, the nice thing about these guys, he said, pointing to the stuff that has 8s and 4s and 2s, the nice thing about those ones is we can work out log base 2 of 2 is 3. And log base 2 of 2 is 3, and together that's 6, which is log base 2 of 64, right? It is 6, so that's true, right? This is 2 and 4. 2 plus 4 is 6. This is 1 and 5. 1 plus 5 is 6. This is 0 and 6, and 0 plus 6 is 6. This is, I don't know, I mean, somewhere between 1 and 2, right? The exponent, I raised the base 2 in order to get the number 3. Well, 2 to the 1 is 2, and 2 squared is 4, so it's between 1 and 2. But that's all we know, right? We don't know what the actual value is.
Would there be a way to figure that out with the calculator?
There is. And actually, oh, you know what? I don't want to go there. There's a way to figure that out, and I need to scroll. There we go. There's a way to figure that out. It's called the base change formula, but it's not until later. Okay, so we'll learn it, but we're not learning it today. It's on your sheet. They do give it to you.
Which one is it?
Well, I can't tell you that yet.
N.
Don't want to ruin it.
Log A, M to the N.
No. Okay, so what if we're going to do the difference of logs? So same deal, right? You can fill this in. We'll do the first one together. Log base 2 of 64 is 6. Log base 2 of 4 is 2. 6 minus 2 is 4. And 4 is equal to log base 2 of 16. Okay, so you want to fill in the rest of these, right? And I will pause this. So you can fill that in, check your answers. Let me know if I messed up, because I do frequently. So. And not always on purpose, actually not often on purpose.
Never on purpose.
Nah, sometimes, but very rarely. If I mess up on purpose, then I stop and wait. If I just mess up, then I usually don't stop and wait. I just keep going.
You said that one of your bottom ones wrong.
The bottom one is wrong.
Log base 2 of 2 is that equal
Oh.
1. So then 7 minus 6 is 1.
Well, let's fix that then. There, see? As if I had done that on purpose for teaching purposes. Good stuff. It's like, you know, so you're missing classes, but you know your stuff. That's good.
Oh, you're hungry.
Okay, so for each, what's a logarithm again?
An exponent.
An exponent. Remember the exponent laws? Okay, well, we'll do that in a second. Let's finish this off. So, take a look at the pattern that's there, right? A lot of math is just looking at patterns, right? That's why we're doing this. So we're doing this so that we can come up with an idea of what would log base 2 of 32 minus log base 2 of 2 be? Or not 2 be.
5 minus.
I just want a number here. Log base 2 of. Look at the pattern.
6. Yes.
Did we get it right?
Wouldn't it be 32 divided by 2, so 16?
Yeah.
What?
Log base 2 of 128 minus log base 2 of 16.
128 minus 16.
8. Log base 2 of 256. Take one of each. Minus log base 2 of 4.
64.
See, there'll be a lot less take one of each in this video because period 1 rolls in like.
16.
And 16? Okay. From your investigation, complete the following law of logarithms.
We're almost done. Yes.
No, we're not even close. Yeah, we're close. There's not much more. I want to just do some examples for you because you guys said we need lots, or we would like lots of examples. I'd like to see a lot of examples. Log base a of m minus log base a of n is equal to log base a of m over n. M over n. Yeah, I know. And log base a of
M over N.
is equal to log base a of m minus. In other words, or actually in words, because the other one's a formula and these are actual words, the difference of the logs of two numbers, this is the difference of the logs, is equal to the log of the, hey, they actually did come up with quotient in the other class. Although I believe it took some prompting. Of the two numbers, or the log of the is equal to the.
You know, I think you should bring Jessica and Justin to your first period class.
I know.
You can just sit there and be like,
You could throw out the number. Well, the problem with.
well, the annoying thing is I know them in class, and as soon as it comes to the test, I'm like,
But I knew it. Okay, last one. It's like take 2, right? Logs of powers. And this is actually a really important one, which is going to come in like tomorrow's lesson. This is the one that's going to allow you to solve exponential equations, right? Where you don't know the exponent, right? We're trying to find that n. So we've got like, 500 equals 100 times 1.02 to the n, and we want to find n. The only way we can do that right now is to graph it. We're going to learn how logs can help us solve that, so we don't have to do it graphically. Okay, so log base 3 of 2 to the 5th. Well, 2 to the 5th is 2 times 2 times 2, 5 times. This is a product. The product of a log, the log of a product can be written as the sum of the individual logs. So we take log base 3 of this plus log base 3 of this plus log base 3 and so on, right? And we've got 1, 2, 3, 4, 5 of them, so it's 5 times log base 3 of 2.
That's confusing.
Now, we're going to do the process 2 more times, right? So we can write it out. We can see what it, so it's going to be log base 6 of 4 cubed, which is 4 times 4 times 4, That's a product. A product can always be written as the sum of individual logs. Or it's the log of a product is the sum of the individual logs. So plus log base 6 of 4 plus.
Makes sense now.
Good.
Still don't get it.
So how many log base 6 of 4s do I have?
3.
3, right? So 3 times log base 6, 4, right? Because multiplication is just really repeated addition, right? If you're repeating addition, you can simplify that. And then we want to do the same thing with 7 to the 4th. So how many 7s am I going to write?
4.
4 of them. And then it's going to become the sum of 4 of these. Now make sure you're writing the base in. If it has, what if I don't put a base down? What base is it?
10.
Right. And how many log base 5 7s do we have? Okay, so it would be 4 times log base 5 7. Now if we look at, we've got 3 examples there, right? We're using inductive reasoning. Remember back to reasoning? So we're looking at a pattern here. And we're saying, okay, so what's log base a of m to the exponent n?
It's n times log a to the 10.
Yep. So it's n times log base a to the m. And to me, that's about the most frequently used and most useful form of the laws of logs. In other words, or actually in words, because that's a formula. So whereas the log of a power is equal to the, so what's n called? The exponent times the log of the base. So the exponent times the log of the base of the power. So, and this works both ways too, but both ways in the sense of, if it's written as a power, you can move the exponent in front. If you see a number in front of the log, you can move it into the log by putting it as a power, right? By putting it as the exponent. And we'll do some examples. And what I'm going to do is just work through the textbook examples. We'll just go through them together. I'll just explain, what's going on. And yeah, because I got lazy. I did this. Usually I leave them for you, but I was going to find somewhere in chapter 7. And you don't need to turn to this, okay? Okay, so we're going to start with, so first one is use the exponent laws. Oh, so let's talk about exponent laws for a second. If I have powers with the same base and I multiply them, what do I do with the exponents? You add them. If I add individual logs, what are logs again? They're exponents. So if I add the exponents, right, I'm really doing what the exponent law says is to multiply powers with the same base, right? When you multiply powers with the same base, you add the exponents. When you add the exponents, you're turning it into a product, right? You're turning the addition into a multiply, okay? Because the laws of logs are really just the exponent laws, right? Exponent laws, multiply powers with the same base, add the exponents. Log laws, add 2 logs together. Logs, they're just exponents. What do you get? The product. So this explanation is use exponent laws to explain why. So it's explain why log 12, what's the base on this log? 10. And what's the answer going to be? What's log 12 plus log 2?
Log 4 plus log 10.
Oh, that teaching gone to waste.
Log 4.
Yeah. The sum of the logs is the log of the product, right? So it's log 24. Okay? So here's how we're going to do it. Here's how we're going to look at this, right? We'll just say, let's take log base 12 and let's change it into exponential form, right? So we know that 10, what is log base 12? It's a log, which is an exponent, which is a number. The number is the number that I go 10 to the power of something gives me 12. That something is going to be between 1 and 2, because 10 to the 1 is 10, and 10 squared is 100. It's going to be very close to 1 and not close to 2. Right? It's going to be like 10 to the 1 point something. Okay? But whatever it is, we could work it out on a calculator, right? But we can also do this by changing the form. So we could say, let x equal log 12, and let y equal log 2. So I have the logarithmic form. Now you'll note that one of the formulas on your formula sheet is changing between logarithmic and exponential form, right? So this says if x is equal to log base a of y, which is what we have here, x is equal to log base a of y. What's our base? 10. Then y, so 12 is equal to 10 to the power x. Right? And those two statements are exactly the same. Right? 12 is 10 to the power x, and x is log base 10 of 12. Because what does log say? It says, what's the exponent that I raise the base 10 to in order to get the number 12? Or this just says 10 to the what is 12, 10 to the what is 12. So what's this one in exponential form?
2 equals 10 power y.
Yeah, so 2 is equal to 10 to the power of y. Now, we know that 12 times 2 is 24, right? So we write 12 times 2 is 24. And instead of 12, we're going to write 10 to the power x, right? Because we know 12 is the same as 10 to the x. And instead of 2, what are we going to write? 2 is 10 to the y, and that's equal to 24. Right? So all we've done is we've replaced 12 and 2 with their exponential equivalents, right? And what do we do when we multiply powers with the same base? So 10 to the x plus y is equal to 24.
But it's multiplied.
Yeah. We multiply powers with the same base. What do you do with the exponents? You add them. That's what we're doing, right?
But why did we have to do all that work to just figure that out?
All right, so then we're going to go one more step and just end up back with the original statement we started with. Okay, and then I'll say, here's why we did this, right? Just to show you in exponential form why the law works out, right? So let's convert this to a log. So what's the base? Okay, log base 10. So I'm not going to write a base, right? So log, what's the value we're going to end up with?
X. 24.
24. And what's that equal to? The exponent, right? So this is exponential form, this is logarithmic form, right? You need to be able to translate back and forth between the two. Better than the people who wrote this thing first semester did, because they weren't really that good at it. Right? I saw the marks. Like converting exponential logarithmic form was like 30% of the class got it right. So we want to do better. Okay? So you just say the log. What's the base? 10. Don't need to write the base. What's the value? I'm going to end up with 24, and that's equal to, a log is an exponent. That's the exponent, so it goes down here. That's the base. It goes there. That's the value. It goes there. Okay? And I think that's what we were kind of trying to show up here, right? That log of 12 plus log of 2 is log 24, and log 24 is x plus y, and x and y are log 12 and log 2, right? So I can now go down here and replace this and say it's log 12 plus log 2. Okay, so now I replace the x and y back with what we originally replaced them with, right, which is log 12 and log 2. And that's just showing you how that exponent law works. How that law of logs works, but by doing it by putting things into exponential form, right? So you can see that, oh yeah, I'm adding the exponents to get this thing. And what's a log? It's just an exponent. Okay, I let this thing be the x and the y, and then we do to the 10. You could also work this up looking backwards, going up instead of down, and it just don't make some sense, right, as to the flow of it. Okay, that's the why, which you never really need to know, right? It's more the how. It's like, let's use this. Okay, how do we use these things? So let's do a couple of examples, like about 3 or 4. Log base 2, 5 plus log base 2, 6.4. And we are going to do what with this? We're going to simplify. So simplify. And this will be A. So what's log base 2 of 5? I don't know. Bigger than 2, smaller than 3, but I don't know what it is, right? And I have no way to figure out what that is. Well, I mean, I guess we could go into exponential form, say 2 to the x is equal to 5, and then graph it. Okay, but right now, can't solve it. But this is the sum of individual logs, so what's that equal to? The log of? Log base 2 of? Of the product, right? What's 5 times 6.4? 32. What's the log base 2 of 32, or in other words, 2 to the power of what gives me 32?
5.
5. So log base 2, 5 plus log base 2, 64 is 5.
That's 64, 6.4.
Okay? So you can simplify that, right? That's a question that I would ask as a show your work. So determine, algebraically determine, which means you got to show your work. So it's just saying, okay, I've got the sum of 2 logs. I look at my formula sheet, which you're going to do every time you use a formula on that diploma. I don't care how well you think you know the formula. Look at the sheet, honestly. It's not worth getting it wrong because you didn't know it quite as well as you thought you did. Okay? So seriously, like when I do 30-1, there's some formulas on that sheet I look at every time, right? Like sine A plus B. I kind of know what it is, but I'd rather be sure of it, right? Well, there's no point. You got nothing, you got 3 hours to write this thing. You can take a moment to look at the formula sheet, which you're going to tear off and have there anyways. Okay? Like especially quadratic formula, it's easy to forget part of it. So the only stuff you got to memorize is stuff that isn't on here, right? So I might point out and say to you, you really need to be familiar with this formula. Okay, even if they might give it to you, you should at least be familiar with it. Okay, next one. So log base 5 of 100. So 5 to the what is 100? I mean, I don't know. I mean, it's 5 squared is 25, and 5 cubed is 125. So it's between 2 and 3, probably closer to 3, but I don't know. And actually, I don't care. Minus log base 5 of 4. Yeah, so you go log, remember the base, 100 divided by 4, which is 25. And what's log base 5 of 25? Exactly. Okay, so when I see that, I always just say to myself, 5 to the what is 25? 5 squared. Okay, so what we've got is an expression that we couldn't do anything with, right? Log base 500, don't know. Don't even know how to do that. Log base 5 of 4, don't know. Less than 1, but otherwise I don't know, and I don't even know how to do that. But when you put them together using the law, you end up with a quotient, 100 over 4, which is 25, log base 5, 25 is.
Will they ever be different bases?
So different, like log base 5 of this and log base 3 or something?
Yeah, will they ever do that?
If they do, you can't use any of the formulas.
So
Okay, so no.
Okay.
I mean, now, having said that, you said, but hey, on the test you gave us, the other in the cube, you had 2 different bases, right? But they were stuff you could work out.
But like algebraic with it.
Yeah, well, it was like log base 5 of 25 and log base 2 of 8. Okay, 2 and 3, 2 plus 3 is 5.
Not fair. Then I'm just going to get that right on the test now.
Okay, no, I gave different numbers. Okay, a couple more.
I love it.
Log base 3 of 18, so again, this will be simplify. Plus log base 3 of 3 halves. Individually, we have no idea. We can't work them out, right? I mean, 18 is not a power of 3, and 3 halves is not a power of 3. But the laws of logs say that this is equivalent to log base 3 of 18 times 3 halves, which somebody said was 27. And log base 3 of 27 is 3. Okay, 1 or 2 more?
1.
Maybe. Log base 540 minus 3 log base 5 of 2. Now we got a little problem here, right? The formula says log base a of m and log base a of n. We do have the same bases, they're both base 5, but we now have that 3 in there. So it won't work with the formula. But how do we get rid of the 3?
Multiply by 2.
Couldn't you just literally multiply everything by 3?
Nope. You can use one of the does that we haven't used yet.
Oh, the n times log, or the exponent times.
So what do I do to this 3?
You turn into the exponent on n.
So it becomes log base 5 40 minus what?
Log base 5 2 to the 3.
Maybe we should do this on a test.
Yeah.
It's in a class. It's like,
I know,
it's not
but
that you don't do badly on them, right? But
No, I do. 70 is better.
well, okay. Depends on your. For some people, 70 is like, wow, if I could get 70. What's 2 to the 3?
8.
What are we going to do with the difference? We're going to divide, right? So we turn the difference, it's the difference of individual logs, right? So you've got log, and it's going to become a single log. So it's log base 5 of 40 over 8, which is 5, and log base 5 of 5 is 1. Key ideas are on the top of page 446. I mean, they're usually right above or before whatever the assignment is. Assignments on 447, you should probably do them all. They're really not that hard, right? And the idea is by doing enough of them, when you hit one on the test, it's not going to be sort of like, oh, I saw him do it, it looked easy. Right now it's, yeah, this is all easy, right? I saw you do it, it looked easy. And it is easy right now, but, after the break, if you haven't done any, you just got to practice a bit, and then, you want to pick some up at the end of the break. Go back through and do a little bit of homework from each of the sections. So on that Monday, Sunday, Monday, whatever. Go back through, do a little bit from each of the sections just to get up to speed a bit. I think we've got one new lesson after the break, then a review, and then the test.
Modeling down.
All right. And then what I'm going to do now is I'm going to stop this. So I'll replace that.